Hey guys, welcome in, and in today's video we are taking the Glade Air Spray refreshener and making it smart. So let's cue the intro and let's start with the video. Welcome back. So as I said, today we are going to convert the Glade Air Spray to smarter spray. So let's establish some parameters, what I'm trying to achieve, and even why I want to do it. So first of all, this spray sprays about every 8 minutes or so, and it's kind of wasteful, and to me it's really annoying because it doesn't know when someone walks next to it, and every time I'm walking next to one of them, it seems like Murphy Law is there and it sprays me in my face. So I want to solve that. The second thing, those sprays are very strong and I'm a little bit sensitive to smells. So the idea is that I want the house to be refreshed and smelling nice when I want it, not every periodic time that the machine chooses for me. So now let's talk about what I'm trying to achieve and what parameters I want to stay in. So first of all, this thing needs to look as stock as I can make it. So first thing, make it look stock. Second thing, keep the same functionality as if it was a dumb device, not a smart device. So we have a button here on top that if I press it, the machine will spray, and I want to keep it that way. So if we have someone here that doesn't know it's smart, can still operate it as it should be. The third and last thing is to make it plugged in. So out of the box, it operates on batteries. I think it's 2 AAA batteries. And I don't want to go and try to operate it, don't understand why it's not working because it ran out of batteries. I don't like switching batteries, so it has to be plugged in. That way I know I can count on it and I know it's going to work when I need it. So let's go to the computer and let's design a PCB.
Heat up the iron, watch it glow. Connecting dreams with steady hands. Building worlds from circuit plans. PCB's a canvas, green and white. Traces weaving like rivers collide. LED shining in vibrant hue. RGB dancing just for you. Wire by wire, the future's bright. Capacitors charge under the light. Resistors holding the chaos in line. Microcontrollers, the brain's design. A spool of wire, a steady grip. Tiny components never slip. The hum of creation fills the air. A masterpiece crafted with care. Flashing lights that tell a tale. Electric symphony will never fail. From every pin, a signal streams. Living in a world of tech dreams. Wire by wire, the future's bright. Capacitors charge under the light. Resistors holding the chaos in line. Microcontrollers, the brain's design.
Okay, so now what we're going to do is we're going to take our assembled PCB and we're going to install the software on it. Now there are two ways to basically do it. So it depends if you're a more advanced user and you already have ESPHome running on your Home Assistant or in your server, then you can just download the YAML and you can see the code here, you can edit it. And if you install everything and connect everything, and the motor spins the wrong direction, so let's say it spins counterclockwise instead of clockwise first, then you come to this code here, and I also added some remarks here, and you just switch between the 3 and 4. So you put 4 here and 3 here. You're gonna send the update via OTA again, and then the motor will spin the correct way. If you don't want to change it in the code, you can just desolder the motor wire and switch them. But what we're going to do now is we're going to use the two bin files. So we have two recompiled bin files that one of them will spin the motor clockwise and one of them going to spin the motor counterclockwise. So if we finish with this process and we finish with assembling everything, and while we're doing the test for the motor, we see that the motor spins the wrong way, we can come back to this process and install the other bin file, and that will fix the issue. Or also here, if you are into soldering, you can just desolder those wires from the board and switch them. So for now, we're going to install bin number 1. So we're going to press connect. We're going to have this pop-up window. We are connecting the PCB to the computer, and we are seeing we have something here popped up, COM4 on my computer. For you guys, it's going to be something else. We're going to press connect. We're going to see here it is marked as connected, which is great. We're going to press on the install, and here we're going to press choose file. Now, as I said again, you're going to have two bin files. Here we're going to install number 1, so we're going to press on it and press install. Now, this is going to take a few moments, but if you get this error that we see in here, you probably need to press the boot button while connecting the PCB. So let's do that again. Press the boot button, connect the PCB to the computer, and release the boot button, and hopefully that will solve the problem. Yes, so now as you see, now it's working. It says erasing, and let's give it a few moments to install, and we'll be back after. And we're done. So we can press close, and basically the PCB is now working and installed. So the last thing we need to do here is actually make the PCB connect to our home network. So I'm going to reset the PCB. I'm disconnecting it and connecting it again. And now let's go to our phone and let's connect the PCB to the Wi-Fi. So now we're going to connect to the Wi-Fi. So the ESP is going to emit a hotspot, and if you go to your phone, you can do it also on your computer, just over the phone. It's easier. If you go to your Wi-Fi, you're going to see Smart Air Freshener. So please press on that and connect to it. Now, some phones are going to automatically open the web page for it, but not all of them. So if your phone is not opening the page, just open Chrome or any browser and go to this address, 192.168.4.1. Then you're going to see this web page. Now, the ESP is going to show you what Wi-Fi networks it sees around, so you can press on it and it will automatically write the SSID here, and then you just add your password and press save. But if you don't see any Wi-Fi's, which is possibility, you can just manually write your SSID and your password and press save. The ESP will reboot and connect to your Wi-Fi network. So now we're done with that. We can go back for the assembly. So yeah, let's do that.
Okay, so now we're going to finish with the final assembly. So we'll need a few stuff. Of course, we'll need our Glade spray. We're going to need the PCB we just made. We're going to need also a sacrificial USB cable we're going to cut and use it as a power in. We'll need some just regular cables to solder some stuff inside, the motors and everything. We'll need a drill because we're going to drill into the plastic shell of the Glade spray, and some other tools, screwdrivers and other stuff, but nothing special. So let's start with the disassembly process. Now the screws here are triangles, specialty kind of bit, so you will need to have a triangle bit or triangle screwdriver. It's a little bit annoying, but yeah, I'll try to replace those bolts, screws. But first thing, let's take all the screws out. We have 4 screws. Now 4 screws are out, you can keep them to reuse them or you can replace them. Now this entire front shell should slide out. And you might need to just push on this area and the entire assembly here will come out. So we are going to work on that in a second, but first thing is I really want to start with drilling the shell and then putting the power cable in because I have some very close here of ADHD and I've done it twice already and I forgot to put the USB cable in and then I solder everything and then I had to resolder them. So yeah, we're gonna do it now so I won't forget. And here you have above the screw thingy to hang it, you have like a tiny dot which look like it comes from it's a trim from the injection molding process. So that's going to be a perfect spot for us to use it as a guide to just drill into it. So okay, so we're gonna do that. That was very easy. If you have a deburring tool, some sort, you can just slowly deburr it so it just will be flush the hole and we don't have anything in here. And yeah, that's basically how it should look. What I'm gonna do now, so I won't forget, I'm gonna take our sacrificial USB cable, I'm gonna open it, I'm gonna cut it, so we're cutting this USB portion out, we don't need that. The micro USB or USB-C, whatever you have, we're gonna just use the other side. I'm gonna slide the cable from the back. And for the cable to stay in here, I'm gonna give myself some spare cable. This is about enough, but I'm going to tie a knot here, so if someone gonna push or pull up the cable, it's not going to put strain on the PCB and all the solders. So just tie it. And now if someone is going to, when you move it, you push that cable, it's not going to move anywhere. So for now, we're going to put the shell aside and we are going to look at this portion. So this is the main assembly. Now we need to go into this PCB and modify it because we want to use that button here. Now you don't have to use it if you don't want to, but in this video I'm going to show you what we need to do to actually use it. So I'm going to take a flat screwdriver and very slowly, carefully, I'm going to separate this portion. It's not screwed in, it's just pressed in with clips, and I'm going to take this entire sub-assembly out, and now I have access to this PCB. So the first thing I'm going to do is I'm going to cut the motor cables because we don't need them to be connected here anymore. I'm going to move the cables aside, and then I'm going to try and carefully pull out the second PCB. Now, when you do that, please be careful with the entire gear assembly because they will fall off. Okay, so I'm going to put that aside. And now I'm going to show you something. I'm going to put a bigger picture on the screen. And I'm going to show you guys that this button, it needs to be modified a little bit, this PCB, because something is going on there and I have no idea. I haven't really looked into it too much. But if you won't cut those traces and modify it, this PCB will send always on signal, something here, and it will send on signal to the our smart PCB we just built. So what we're going to do is we're going to use a knife or a Dremel tool to just cut all of the surrounding traces to the button. So it's only 4 traces, and I'm going to show it in the picture and just do it. And I'm going to do it with a Dremel tool. And after cleaning a little bit of the mess we made here, we still have those 2 points that we're going to solder to them. So let's now take a cable. And now after soldering those 2 wires, we can start assembling, putting this PCB back in. and we are done with this portion with the sub-assembly. So PCB goes in again, and then the entire motor with the gear and PCB assembly is going to be pressed back into their position here. Now make sure that your cables are moving here below this portion and up here, and not coming up from this side, because then it will interrupt with the cable and with us closing everything. So now we are going to start assembling our new smart PCB. But first thing, we need to have flash cutters. And those stuff here, we have those 2 pins here. We are going to cut them away because this is where the PCB is going to sit. And just when you do it, watch out. Those stuff tends to fly. And now we have a place for our PCB to sit. Now, PCB, we have 3 connectors that we need to solder into. One is the button, one is the motor, and the other one is the power in. So we're going to start with the button. The 2 wires from the button are soldering to the top of the PCB where it says button, and now we're going to take the 2 leads of the motor and we're going to solder them to the motor. And the last thing we're going to solder is the power, and over here the power orientation is important, so the polarity I mean. So plus and minus is important, so make sure to solder ground to ground, VCC to VCC. And when you cut and expose your USB cable leads, you might have more than 1 cables there, because you might have a cable that also moves data. So just make sure connect it to 5-volt power supply, and with the multimeter make sure you are you know which one of the wires are the correct ground and VCC. So let's do that. And with the power cables soldered in, we are done with all the soldering portion of this video. So now what we have to do before we assemble everything is we're going to connect it to power, and we're going to test the motor. So as you guys remember, in the software portion, I told you we might have a problem that the motor is going to spin the wrong way, and we're going to test it. And if it's spinning the wrong way, we're going to or desolder the power connectors and switch those cables, or we can do it in software. So let's connect it to power and test it. So after connecting it to the power, making sure the LED is on, we're going to press on the button once, and then we're going to watch the motor. I'm going to press it, and we're going to hear the motor spinning. So we're going to hear it spinning once, going down, and then spinning the second time and going up. That is the desired result. So if the motor is spinning the wrong way first, up and then down, then you'll have to replace those leads or change it in software. But we are all good. So let's continue. So the last thing we're going to do is reverse the process and assemble everything. Now, if you want, you can add a double hot glue here and just make sure to glue the PCB in place. But I'm not going to do it for now, because this will probably going to come apart multiple times for the video. So all we have to do is just make sure we assemble everything the same way. So we're going to push the entire assembly back in place, and now we're going to reverse the process and put the 4 screws back in and screw it in. Now everything in place, we can add the bottle sprayer in and close it and make sure everything looks okay. And yeah, everything looks as it should. So if I press on it, yep, it sprays. For conclusion, we took the Glade Air Spray that was spraying periodically every about 8 or 9 minutes, and we made it smart. We designed our own PCB, we wrote our own code using ESPHome, and now, as you guys can see here, it is connected to Home Assistant. Now, few cool things you can do it, and the idea of the automation and how to use it is up to you guys. For example, I have an automation when I come home, the entire house turn on. So with it, all the Glade air sprays spray and refresh the house. So until I come back home and finishing reparking my car and coming back home, the house smells good, but it also have enough time to dissipate a little bit, so it won't be too strong. Another automation example is if you have an air quality sensor and let's say you're cooking or something like that, and there's a lot of particles in the air, you can also tell the Glade spray at that time to automatically spray and only refresh the house when it actually needs refreshment. In addition, all of the files, of course, is going to be linked in the description below and going to be free. If you guys want to give it a try yourself, the grabber files for the PCB is going to be there, and you can send them to your PCB manufacturer and get them. But if you guys want to support me, and it will actually be the cheapest option because I buy them in bulk, you can go to my website, also linked below, and just get yourself a fully assembled PCB from me. And it gives us a little bit of kickback to continue doing these videos because they are expensive. So guys, I hope you like this video, and I hope you like the follow button and subscribe, and we'll see you on the next video.